Welcome to all the students. My name is Himanshu Yadav. I am an assistant professor within the civil engineering department. Today I am tell you about the wind and seismic analysis subject. Inside this subject we will discuss about the wind and seismic load and analysis it about the structure. When we design a structure, we only consider one of them because both of not fit on any structure simultaneously. Today we will discuss about seismic load analysis in this subject. According to syllabus of Rajasthan Technical University, this is the third unit, design of earthquake resistant structure. Within this unit, we will learn about designing of earthquake resistant structure. This is very helpful for preparing a structure which is resist earthquake waves and also defend all the loads like as shear and other things. In general, as we know, earthquake arise due to collision of earth plate and a lot of waves are generated due to this collision. These include some of the waves that travel above the surface of the earth and some that travel inside the earth. And these waves causes structure damage. And these waves causes structure damage. It is very important for a civil engineer to study about earthquake wave and avoid all the damages in the structure. It is necessary for a civil engineer. And we also know that earthquake resistance structure is prepared by civil engineer, and we prepare a structure which is completely resistance for earthquake. So today, as you see in the pictures, to what extent can earthquake damage a structure and what type of damage we consider in our whole structure life. You see it. This structure completely damaged by the effect of earthquake waves and much more loss of money and humans and other things. It is not recoverable. It is completely wastage and we not use these materials again. So we think about it and we think both these structures, a structure is here, see here, and another structure, this is completely damaged. So what is the reason behind it? Why a structure is completely damaged or why a structure is not damaged like this? You see here, a intermediate structure is damaged but and other two sides structure not damaged. What is the main reason behind it? The reason is design of structure. What is the design procedure? What is the design criteria we consider in designing a structure? If we consider earthquake load in designing, then our structure is safe. Like this is road and this is damaged by earthquake effect. So we also consider earthquake effect in designing a highway like as sub highways, state highways and other things. So this is the picture of what is how to, and in this picture we see that how the earthquakes generate by like this by two plates of earth like as fault then coincides to the collision each other, then generates waves and earthquake. These waves travel on surface and also travel inside the earth, like this. Here, this is point of focus. The point of focus is where the two plates are collision at a point. This point is the point of focus, and this point is also important for understanding the epicenter. You generally see in the newspaper the epicenter of earthquake is here, and epicenter of earthquake like as Bhuj, Gujarat, Delhi, other things like here. The focus and epicenter each other. So here you see this is surface waves. These are generally more dangerous as compared to inside waves, because surface waves are dangerous like as love waves, S waves, P waves, other many waves generate due to earthquake. This is the distance between the epicenter and focus, so we consider it. And this is fault, and fault is also considered. So here you see 4 diagrams, and all the diagrams show the pattern of waves. First is P waves. The P wave pattern like this: expansion, compression. Some place is behave like this expansion, and some place behave like this compression. Second one is S waves. S wave behave like this. These travel on the surface and travel in this form, right? Next is relic waves. This wave travel like this, and S wave and relic waves are different. Next one is love waves. Love wave are different, and this wave is more dangerous as compared to other 3. So if we understand effect of earthquake, then we also understand about love waves. It is very important for understanding the earthquake effect, right? I think you understand about the basic concept of earthquake, and about the what is earthquake, how the effect on structure and other things. So we discuss about general guidelines for earthquake resistant structure. The first one is generally in this design procedure we follow IS code 1893. IS stands for Indian Standard. Code is 1893 2002, and also revised version is 2014. This code is useful for designing a structure for earthquake, and in other words, earthquake resistant structure. First is design of building should be based on seismic codes. So we design as per these 2 IS codes our structure. Second one is integral action of soil foundation superstructure system. So in second criteria we think about it and we know about it. We know this is structure, our structure, and this is ground level. This is foundation of a structure, this is structure. So this is superstructure. The structure above the plinth level is superstructure, and below the ground level is foundation, and below the plinth is also known as foundation. So waves travel like this dotted line in blue color travel like this. So effect in foundation and superstructure are different, so we consider it in both the follow like this. The yellow dotted line shows the buckling of structure and in one direction, and blue line also shows that the buckling of structure in another direction, and this is also called as natural time period, fundamental natural time period. We consider it in design procedure. So next, third one, building should be light in weight and avoid unnecessary masses. How to make a lightweight building? We prepare a lightweight building by reducing the dead load of the structure. And how to reduce the dead load of structure? We reduce dead load by the help of taking green materials which have low weight, and generally we follow IS 875 part 1st for dead load considerations. So in next, structure should not have large height to width ratio, because if we increase height of a structure, then buckling also increase, and buckling is very dangerous. So we generally consider less height to width ratio in design criteria. So this is our criteria. Height to width ratio is as possible as less we take. Next one is column and wall should be continuous without offset from the roof of the foundation. Column and walls are continuous. Next one is beam and column should be of equal width. See here, this is the cross section of column, and we consider this is the beam in red line, this is beam. So the cross section is same here. It is important for transferring the load, because both of them are structure members and play a important role for structure. So next one is the structure should be ductile as far as possible. Ductile and brittle is the property of a material. See here, I explain you what is ductile and what is brittle material. So first one is, this is the rod, a metal rod, like a steel rod, and we consider a tension force in this rod. Second one is a chalk, and we also consider tension in chalk. After that, its permissible limit. What is the effect of tension in both the rods? We see a steel rod behave like this. We know that in steel rod, this diagram is not fair, so I'll prepare again. In steel rod, we see steel rod have much more strain as compared to chalk. This is ductile material, What is the property of ductile material? Ductile material have much more strain before failure, and in brittle material have less than 5% of strain. It's break after 5% strain, it breaks, completely break. Like this choke, you apply tension load, both of them, then it's completely break. In ductile material, cross section area is reduced, and brittle material also same. Next one is structure should be designed on strong column, weak beam concept. This is an important concept as per IS code. Due to buckling, load should be uniformly distributed. We also know that we learn in strength of material what is uniform distributed load, what is uniformly varying load. This is uniformly varying load, and this is point load. It is important. Column and beam should be coaxial. So axis of the column and beam is coaxial. It is very important for transferring the load. Last one is the structure should have balanced lateral resistance. You know what is lateral and longitudinal. In the perpendicular to the direction of force is lateral resistance. So next one is shear wall should be provided for increasing stiffness. What is stiffness? Stiffness is force per unit deflection, load per unit deflection also, that is stiffness. Next one, structure should have low center of mass relative to ground. Next one, avoid ground floor soft story. Next one, there should be uniform distribution of mass, stiffness and strength. 17, there should be a greater emphasis on the quality of construction. Next one, the structure should not be large in the length, nor should they have large plan area. Beam should be free of offset. So these are the guidelines of IS code. Next one is design procedure. This is important for solving the questions and also considering the design, how to design a earthquake resistance structure. Design procedure for earthquake resistant structure. The step first is dead load. First we consider dead load as per IS 875 part first. In dead load we consider floor load and roof load, and next one is live load. We also consider live load, floor load and roof load as per IS 875 part second. These are two IS code using in find out the dead load and live load. This is step first, lumped masses of various floor levels. So see here, this is our structure, the base, and these are stories like as 1, 2, 3, 4, and this is floor, first floor, second floor and third floor, and top one is known as roof. And in design criteria we don't consider live load, we consider only dead load for roof. So live load is 0 for roof. This is an important consideration for solving the questions and prepare a design. Taking load, live load is 0. Okay. Design procedure, step number second, fundamental natural period. This formula is also given in IS 1893 2002 page number 24. what is nature, we also discuss about it, what is fundamental natural period, and also we discuss. See here, this is our building and this is the earthquake waves. This is our surface of earth. So see here, our structure is oscillating like this. I complete the diagram. Our ground level, like this, or structure oscillating like this, right? You see here, that is fundamental natural period. Step number 3 is design seismic base shear, also given in IS 1893 2002. What is the formula? VB equals to AH into W. What is AH and what is W? Total seismic load and horizontal seismic coefficient. Next one is AH. How to find out AH? This is also given in IS 1893 2002. The formula is ZISA upon G ZR. What is Z? That is zone factor. India, the India diagram of India, map of India is divided in many zones. So we consider like this, like 1, 2, 3, 4, 5 zones is also given in IS code. I is importance factor, is also given in IS code, IS 1893 table number 6 page number 18. What is importance? Like as school, hospital building and other building, like as many buildings. SA upon G, average response acceleration coefficient, is also important, given in table page number 16. Reduction coefficient factor R. Next one is step number 4, vertical distribution of base shear. What is the base shear force on every story of the building? So we find out value of base shear for every story, like as Q1, Q2, Q3, Q4 for every story. Is also given in page number 24, IS 1893 clause 7.7.1. What is Q? Design lateral force. WI seismic weight of floor. H height of floor from base, and number of story like this, and height like this. So I think you getting my concepts. Thank you.